Okay, let's have a little look now. This video is going to do Pythagoras. So with Pythagoras, you're given the formula. Don't forget, for a right-angled triangle, your formula is a squared plus b squared is c squared. C squared being the longest side. So when you've got the two shorter sides that you know, I would do something like this. When you don't know the longer, you do know the longer side. So say I know that's 10. And this is 6, and I'm trying to find this one. I would do a Pythagoras takeaway. So 10 squared take away 6 squared is my x squared. So Pythagoras add when you're trying to find the longer side. So that one might have been, maybe I'll do some numbers for you just to make it a bit nicer actually. So if you're trying to find the long side, 3, 4 was this one. Well, 3 squared plus 4 squared is x squared. But when you know the long side, it's a takeaway. Okay, and if you remember that, you're doing well. That's kind of it. So this is dressed up in a lot of perimeter and volume type questions. So let's crack on. So calculate the area of the flag. The area, okay, well I know this area in here is just going to be 40, 10 times 4. Easy enough. But I now need to know the area of a triangle. The area of a triangle is a half times base times height. So I could say, well, the base of that triangle is 10, okay, half times 10. There we go. But the height isn't 13. The height is this value I've shown in here. So we need to use Pythagoras to work out the height. And I'll just put this in like a little cloud. So the height there, the height squared, is going to be equal to 13 squared. Take away 5 squared, because that's 13, which makes that 5 in there. So the height squared is 169. Take away 25, so the height squared is 144. So the square root of 144 is 12. So I know the height is now 12. And yet, when I come to do this question, you don't have to do it in this order. I could do any order I like. I could do a half of 12, which is 6, and 6 times 10 is 60. So, oops, I've done that. So I've got 60, I've got 40. So my final answer, so the area is 60 plus 40, which is 100. So watch out, whenever you see a diagonal, you should be thinking to yourself, probably have to use Pythagoras. Okay, let's try another one. So this one is a calculator question. Calculate the total length of the cable for the bridging. So I need to know this length here. I need to know this length here. So again, a lot of people might have said, well, how do you know it's a Pythagoras question? Well, there's two diagonals, two big diagonals, and I've got two right-angled triangles. So the length of my cable is going to be 300 plus x, where x is this distance over here. And the first thing I'm going to have to do, though, to work out x is work out this height. Okay, so I'm going to use this triangle. I'm going to say that I've got 300 over here. I'm trying to find h, and that's 295. So the longest side is always opposite the right angle. So 300 squared take away 295 squared is my h squared. So let's do that in our calculators. So 300 squared take away 295 squared. So that's 2975. And that's equal to h squared. So h is the square root of that. So that gives me 54.5. And from there I'll use Pythagoras again. So to get the length of my cable, I do apologise for these drawings. I know this is 600. I know that this height is 54.5. And there's my x. So I'll go back up here and say 300 plus, and to get x, I'm going to do 600 squared plus my 54.5 squared, and that's all square rooted, isn't it? So 600 squared plus 54.5 squared. So that's 300 plus the square root of 362,970. So it's 300 plus the square root of that, and that's 602 point, I've got 0.5 when I round it. So all in, it's 902.5. So Yeah, maybe I've rounded something a wee bit off from them. I'm sure there's not a problem there. The point is, when you see a diagonal, you're thinking Pythagoras. To find the longer length, it's a Pythagoras add, but to find one of the shorter lengths, it's a Pythagoras takeaway. Okay, so a nice little question there. Let's go on to this one. We should get that one done as well. Calculate the area. So, how do I get the area of a triangle? You should know that the area is a half multiplied by the base multiplied by the height. So my base is 12 and my height's not 10 because when we talk about these dimensions, they have to be perpendicular to each other, the base and the height. They have to be at 90 degrees. So watch out, if you're a shape like this, well, you would get anything like this, but if you've got a parallelogram or something, if that was your base, the height is not this value here. The height would be the perpendicular distance over here, so maybe that's 10. Okay? So 20 times 10 would give you the area, so it's always perpendicular. Anyway, how do I get the height? Well, I've got to go and use Pythagoras. So I know that this is going to be 10, and on the base it's a half of 12, which is 6. So I know that 10 squared, take away 6 squared, is equal to x squared, so it's 100. Take away 36 is x squared, so then x squared is equal to 64, so x is equal to 8. Fantastic. And again, do this in any order you like. I'm going to half the 12 because that makes life easier. So 6 times 8 is 48 meters squared. So anytime you see a diagonal, you should be thinking Pythagoras. Hope that's helpful.